Okay, our next unit is application of integrals, and everything's dependent upon what we're going to do for the next 2 days, which is finding the area between two curves. So far, we have been finding the area underneath one curve, right? This is function f of x. Say we're going from A to B. We saw that we could break it up into rectangles, right? And then we saw we could do trapezoids, and we finally learned a way of like, what's the best way to figure it out, right? Either product, heck, we had a whole test over this, right? Well, now we're going to look at finding the area between two curves. I want to think again about doing rectangles, okay? We're not going to do them. I just want to think conceptually about it. And if you notice, for all these rectangles, the top of the rectangle hits function f, and the bottom of the rectangle hits function g. We're also going to go between two values from A to B. So if we're trying to find the area between two curves, first of all, we have to find the intersection points. Now, if this is a calculator question, you would just graph it and find the intersection. It'd be awful numbers. If it's on the no calculator, those numbers will be integers, and we're going to practice those today. So to find the area, right, we need to know two things. We need to know the endpoints, which could involve algebra, right? We're going to say those endpoints are A and B. And we also need to know the height of the rectangle, which in this case would be the top curve minus the bottom curve, right? Now there are ones that go sideways. We'll look at that later. Let's just kind of stay within this mode here. So whenever we're doing these, we want to graph it out first, find those intersection points, and then decide if our rectangle, right, our dx thickness rectangle is going to be vertical or horizontal. And I think all these ones will be vertical to start with. All right, and the way I'd write this one out would be the integral. Again, how tall is that rectangle? It's function f minus function g. And we're going to sum up all those rectangles from A to B. Now, one nice thing you will like is for a lot of these, all I want is a setup. We are not going to evaluate these. We're going to spend a whole chapter evaluating these. We might do a couple for practice, but anyway. Okay, here's the first one I want to do. Okay, I'm giving you some equations, and I've already got function f and g written. Now, x equals 1 is a vertical line here, and x equals 2 is a vertical line here. Well, I'm hoping we all can see the region we're dealing with, right? Is this region here. We need to be able to see that region, so it's very important to draw the graph. I think the hardest part on these is actually drawing the graph. Now, if I think about this, I think I can see a rectangle, whereas that rectangle goes between both endpoints. The top of the rectangle is always on function. I think f of x is the quadratic and g of x is the line. So I would say, well, let's find the height of the rectangle, f of x minus g of x. And I can use that notation because in the problem we're defining what function f and function g are. And the endpoints. How far to the left does it start at? I believe it starts when x equals a 1, and it stops when x equals a 2. This is what you would write out. And this is finding the area between two curves. Okay, let's do two more of these, and you've got some homework to do, which I've posted on the classroom. Okay, we have two functions. We need to graph them. This would be a no calculator question. So I think the first thing is, how would I graph this quadratic, right? Well, I believe it does factor to be x plus 1 quantity squared. So that means to be over at a 1. And I can just, it's a parabola that's opening up. And then our other function is this. Y-intercept is 5, and the slope is 2. All right. So it kind of goes like this. Now, this is just a sketch of the graph, right? We do need to find these two intersection points. And the best way to do that is to set the two equations equal to each other. Again, if this was a calculator problem, you would just graph it on your calculator and find the intersection points. Okay, so I've got that. X squared plus 2x plus 1 equals 2x plus 5. I think the 2x's cancel. Bring the 1 to the other side. So the x value, this is at a -2, and this is at a +2. I do believe we're going to be doing vertical rectangles, because the top of that rectangle is always going to be on the line, and the bottom of the rectangle is always going to be on the curve. So our integral will be the top minus the bottom, right? So our top curve minus the bottom curve. And it goes from -2 to 2. That is our setup. Again, not too terrible. Okay, let's look at one more. And again, I can use F and G because we have defined what those are. Okay, now example number 3. So again, we need to draw the graph of this first. All right, I know this first equation is a parabola opening upside down. I'm not sure where exactly it is, but I do remember from algebra that the x value of the vertex is -b over 2a. So -4 over -2, which is a 2. So I know that the parabola is opening down from there. If I want to find the height of that, I can replace the x values with 2's. And I think I get 6 from that. So here I am, and my parabola is opening down. Okay, now we draw the other one, y equals x plus 2. There we go. Now again, not a great sketch, but it suffices, right? We need to find these intersection points. So again, we are going to set the two equations equal to each other. Let's see here. -x squared plus 3x equals 0. Let's factor out an x. So x is equal to 0, and x is equal to 3. So this point's at 3, and this point here is at 0. Yeah, I can tell my graph was not the best one, but again, I do know which graph is on the top and which graph is on the bottom, right? Okay, so our rectangles are going to be vertical, because the top of that rectangle is always going to be on the blue graph, and the bottom of it's always going to be on the green one. So I'm going to set out my integral. How tall is that? Well, top minus bottom, and since these are not defined, I need to write them out. Minus the bottom curve. Please remember the parentheses here, because that's a big source of error on people. And we're going from 0 to 3. This will be it. Again, not too bad. When I come back, we're going to do some more of these and continue practicing them, all right? I will see you all tomorrow.